Ni hao, and good morning, good afternoon, or good evening, wherever you're joining us from today. It's great to be presenting at COMPUTEX again. I've been in the chip industry for more years than I care to remember, and COMPUTEX has always been an event I look forward to attending every year. And in my opinion, this event represents the heartbeat of the compute industry. Now, I'm very confident that next year I'll have the opportunity to present to you in person, as well as meet with many of you who make ARM the world's largest compute ecosystem. We've seen tremendous growth over the past decade. Just over 10 years ago, our partners shipped nearly 7 billion ARM chips in a single year. Now, fast forward to 2021, and that same ecosystem has recently shipped more than 7 billion ARM chips in a single quarter. And with more than 190 billion ARM-based chips shipped, the ARM architecture is clearly the world's most pervasive and indispensable compute architecture. Deployments of ARM-based devices are on such an accelerated pace that I'm quite confident that 100% of the world's digitally shared data will soon be securely processed on ARM-based technology at some point in its life, either at the endpoint, or in the data networks, or the cloud. Now, of course, with such great demand for ARM technology, we won't ever stop innovating at ARM. The ARM architecture is not static. We continue to evolve to meet the ever-changing needs of the computing world. In the 10 years since we introduced the 64-bit processing in ARM v8, you can see that we've added a number of extensions and features, including a number of security enhancements. But bringing a new architecture to market is in fact a massive undertaking. And in fact, it's really a once-in-a-decade occurrence for us. And recently we announced ARM v9, the next major milestone for the ARM architecture for the decade ahead. ARM v9 will apply across all our CPUs, from those smallest microcontrollers to the largest server-based designs. There are lots of great new innovations in ARM v9, including increased performance and efficiency. But as ARM v9 will be at the forefront of the next 300 billion ARM chips, the additional security benefits it offers will be essential in securing the world's data. Securing the world's data is the greatest technology challenge in the world today, and the threats to our data never stop, which is why the ARM v9 roadmap introduces the ARM confidential compute architecture. This technology shields portions of code and data from access or modification while in use, even from privileged software, by performing computation in a hardware-based secure environment. ARM confidential compute introduces the concept of dynamically created realms, usable by all applications, in a region that is separate from both the secure and non-secure worlds. Now, for example, in business applications, realms can protect commercially sensitive data and code from the rest of the system while it's in use, at rest, or in transit. In addition to adding new data protection layers, we've taken a vital step in improving the security of the world's software. ARM has collaborated with Google to develop a technology called memory tagging extensions to uncover vulnerabilities before they can ever be exploited. Support of memory tagging extensions are an integral part of the first generation of ARM v9 CPUs available in devices next year. ARM v9 will play a critical role in securing our digital future and increasing our trust in intelligent devices which process our personal and professional data. Now, for example, we've already seen increased use of technology to record and manage personal health data during the pandemic. It's just one of the several inevitable compute trends that accelerated during this time. As part of this dynamic, healthcare and other industries are accelerating their adoption of machine learning and artificial intelligence. For example, more than half of the 500 healthcare executives surveyed by Optum said that they are accelerating or expanding their AI deployment timelines in response to the pandemic. And according to a recent KPMG survey of enterprise decision makers, half of the respondents say that their organizations sped up the adoption of AI in direct response. What all this means for the compute industry is that we have an opportunity to accelerate ubiquitous intelligence across all our devices. But doing this means asking our devices to run incredibly complex workloads with greater performance and energy efficiency that's available today. The nature of these complex workloads is such that a one-size-fits-all chip designed for general-purpose compute with big single-threaded processors are simply not enough. Modern SoCs with dedicated compute blocks for different tasks and greater efficiency are required. ARM has been enabling an SoC revolution for several years now, as mobile and IoT devices have always had stringent requirements related to energy efficiency and cost. These devices are deployed in such large volumes that have inevitably meant designing customized chips. Beyond mobile and IoT, we've seen lower volume applications with even tougher requirements, such as aerospace, increasingly looking to the ARM ecosystem for purpose-built SoCs. Now, we're entering a new era of compute where AI and ML will cut across every computing environment and will be enabled by specialized processing. ARM has been enabling our partners with the flexibility to build specialized processing for 30 years. But now, we're on such an accelerated pace of billions of ARM-based chips shipped every quarter, I can confidently say that the next decade of compute will be one where specialized processing becomes the new normal for computing, and all of this built on the foundation of the ARM v9 architecture. ARM's approach of providing a diverse suite of IP components such as CPUs, NPUs, and GPUs allows our partners to develop purpose-built systems they need for ubiquitous intelligence and other emerging challenges. Different computing problems need different mixes of compute components. In IoT, for example, many devices need to interpret their worlds, and a combination of our Cortex-M cores and Ethos Micro neural processors are a perfect solution. In automotive systems, partners will increasingly be combining many large and small CPUs with GPUs, NPUs, and their own IP to generate the right computing solution for the new autonomous systems. Now, this is happening across the entire computing spectrum, including client solutions and our Neoverse platform for edge-to-cloud infrastructure. We know that digital experiences are richer and more dynamic than ever before, but growing challenges brought forth by a combination of 5G, AI, and the end of Moore's Law requires a new approach. That approach needs to be scalable and flexible across entire systems. We call this total compute, a blueprint to address tough challenges around the need for higher performance compute and increasingly complex systems. Total compute solutions bring together the powerful assets of the ARM platform, from software, tools, physical IP, and standards to our full suite of hardware IP to deliver flexible solutions across premium, performance, and efficiency market tiers. Our partners can then in turn build the best products and solutions while unlocking new experiences for the entire ecosystem. Consumers will be able to immerse themselves in stunning, lifelike 4K and 8K content on their TVs, with flawless user interface and even faster app launching times. With smartphones, they can record and edit richer and richer content, and then share instantly over high-speed 5G networks, and their ARM-based laptops will increase productivity and stretch battery life to days, not just hours. Now, all of this will be delivered on the secure foundations of our new ARM v9 architecture, enabling trusted digital services for the next decade. This is the future of specialized processing. Now, last week, we launched our latest manifestation of total compute solutions and our first Cortex CPUs on ARM v9. Cortex X2 is our first v9 flagship CPU for ultimate performance from the Cortex Custom X program. X2 delivers another 16% improvement in performance compared to Cortex X1, running on the same process at the same frequency. Cortex A710, it's our first v9 big CPU, with a remarkable 30% energy efficiency gain over our previous generation, Cortex A78. Now, our first new little core in 4 years is the Cortex A510, which delivers an impressive 35% performance improvement compared to the previous generation, Cortex A55, making it our most capable little core ever. The Cortex A510 hits performance levels approaching those of previous generation big cores, making it ideal for smartphone and home markets with a power profile that's perfect for the wearables market. For uncompromised performance, the v9 CPU cluster is now supported by a brand new scalable dynamic shared unit. This allows a maximum of 8 Cortex X2 cores while still staying true to ARM's DNA, and that's efficiency. The potential for performance in this new CPU system will open up many possibilities across different markets and devices, and I'd like to touch on one just in particular. Now, it's still early in the ARM laptop adoption curve, and we're beginning to see huge momentum on many fronts. I'm excited by how this technology can scale. A new laptop solution could see Cortex X2 deliver 40% more peak single-thread performance when compared to 2020 mainstream laptop silicon, yet provide all-day battery life. Now, that unleashes all kinds of new possibilities. The visual experience also remains critical to how consumers interact with and enjoy their devices. So this year, we're introducing the widest range of Mali GPUs we've ever announced at a single launch, tailored to the needs of the client markets and complementing the ARM v9 CPUs and our total compute solutions. Now, Mali continues to be the world's #1 shipping graphics processor, with yet again more than 1 billion GPUs shipped by our partners in the last year. But it's not just volume where Mali leads the way. It's also the most scalable and versatile GPU available, with an ambitious performance trajectory to match. Mali G710 is the highest performing GPU from ARM ever. Aimed at flagship and premium smartphones in the growing Chromebook market, it delivers a 20% performance improvement and 35% ML uplift over the previous generation. Mali G510 and Mali G310 bring new features and technologies to the performance and ultra-efficient segments, powering premium graphic experiences from a wide range of devices, from digital TVs and set-top boxes through VR, AR, and wearables. Our solutions approach with Total Compute does not stop with our client offerings, as we're applying these design principles across our entire IP portfolio. This includes our ARM Neoverse platform for edge-to-cloud infrastructure solutions, targeting 4 key segments: hyperscale and cloud computing, 5G, HPC, and infrastructure edge. These are the markets that realize the future of computing, which require them to break away from the status quo of one-size-fits-all, with more flexibility and the design freedom to achieve the right level of compute for the right application. Now, we give our partners incredible headroom for innovation in these areas, whereas traditional architectures have really limited them. For example, if one of our silicon partners or cloud service providers wanted to build a specialized SoC solution tuned for video processing and streaming, they can customize the number of CPU cores and match with the right level of GPU, storage interconnect, and interfaces to ensure they have the right amount of performance, utilization, and efficiency. This ability to customize is why Amazon Web Services is realizing unique benefits with its Neoverse-based Graviton 2 SoC, and why cloud providers such as Alibaba, Tencent, and Oracle are seeing really impressive results in their initial testing or deployment of Neoverse-based platforms. Enabling specialized processing has been a focal point for us since the inception of the Neoverse line of platforms, given the variety of workloads and applications. A trend we expect to see accelerated with the recent launch of our next-generation ARM Neoverse platforms, the Neoverse V1 and N2. Neoverse V1 is the first in a new performance computing tier, delivering significant uplifts in vector and machine learning, along with high CPU performance, while still providing the SoC design flexibility they require. The Neoverse N2 platform is the first based on the ARM v9 with improvements to security, power efficiency, and performance. It delivers 40% higher single-threaded performance compared to N1 at the same level of power and area efficiency. Now, Neoverse N2 is also the first platform to feature SVE2, an ARM v9 feature that drives large improvements in cloud-to-edge performance efficiency. For a broader set of use cases like machine learning, digital signal processing, multimedia, and 5G systems, SVE2 not only brings performance, but also the ease of programming and portability, which is a key technology at the heart of the ARM-based Fugaku supercomputer, currently the world's fastest. There's a lot of momentum behind ARM technology for infrastructure, as shown by several major announcements at NVIDIA's recent GTC event last April, starting with Grace. Grace is NVIDIA's first ARM-based data center CPU. It will deliver 10x the performance of today's fastest server, running some of the most complex high-performance computing workloads. Next, NVIDIA and Marvell are collaborating to bring GPU acceleration to Octeon, the ARM-based family of data processing units from Marvell for enterprise computing, 5G infrastructure, and edge applications. And finally, a new NVIDIA ARM HPC developer kit. This kit includes an Ampere Ultra CPU, which contains 80 Neoverse cores running up to 3.3 gigahertz, dual NVIDIA A100 GPUs, each of those delivering 312 teraflops of floating-point deep learning ML performance, and 2 NVIDIA Bluefield 2 DPUs. The National Center for High Performance Computing in Taiwan is one of several computing centers initially deploying this dev kit. And scaling edge to endpoint, ARM is enabling specialized processing solutions across a diverse range of IoT solutions. And similar to how ARM powered the smartphone revolution, we now have the same opportunity to do that for IoT. The combination of IoT and ubiquitous intelligence will ultimately change our lives, much the way smartphones did. Smartphones and related devices such as tablets and wearables have resulted in the data we generate growing at an exponential rate. It's now estimated that humans produce 1.7 megabytes of data every second. However, IoT, which will see far more connected devices than there are people on this planet, is poised to generate more amounts of data over a massive variety of devices, including intelligent sensors and actuators. These are capable of monitoring anything from vibration to voice to vision, really along with almost anything else one could imagine. These devices are everywhere, from industrial sites to security cameras, smart watches, smart homes, even vehicles with increasing levels of autonomy. And with more than 70 billion ARM Cortex-M class chips shipped to date, IoT runs on ARM. Because we are the industry standard for IoT, it's our responsibility to remove the barriers for deployment of IoT at scale by working with our ecosystem around areas such as security and safety. However, to realize the promise of IoT requires a shift from processing learning data out of the cloud onto endpoints at the edge, as many companies are not even close to maximizing value from their data. Just look at a recent study by Strategy Analytics, which determined that only 1 to 12% of company data is being analyzed because sending vast amounts of unstructured data to the cloud is expensive, causes bottlenecks. It's highly inefficient in terms of energy bandwidth and computing power. The ability to do advanced localized processing and analytics can really help to reduce latency for critical applications, lower dependencies on the cloud, and better manage the deluge of data being generated by all these IoT devices. To ensure this happens, we are committed to enabling on-device machine learning from the tiniest sensors to voice assistants to industrial applications. We envision a world where no device is left behind. More on-device intelligence means that smaller cost-sensitive devices can be smarter and more capable while benefiting from greater privacy and reliability due to less reliance on the cloud or the web. To achieve this, we're enabling device makers and developers to deliver machine learning locally on billions of devices. And last year, we brought to market a new suite of AI-capable processors to enable our partners to build specialized IoT solutions to ensure on-device machine learning on the tiniest devices can now become commonplace across a vast range of life-changing applications. Here you can see that ARM offers the broadest range of ML solutions for AI endpoints that scale up to 100 TOPS. Our latest solution combines the Cortex-M55 and the industry's first micro neural processing unit, the Ethos U55. These deliver a massive 480x performance uplift for ML processing relative to previous solutions. To further enable our partners to bring specialized processing to endpoint AI, we've evolved our business model to make ARM IP more accessible than ever. ARM Flexible Access is a fast and low-risk path to market for endpoint AI applications. This has been one of our most successful offerings ever. In just under 2 years, we've signed up more than 90 partners. More than half of these are first-time ARM partners, the majority being early-stage innovative startups. ARM Flexible Access allows SoC designers to download, experiment, design, and manufacture with a wide range of ARM IP. In addition, tools, training, and engineering support are also provided. Now, as the license fees are not payable until the finished design is ready to tape out, Flexible Access members can experiment, start, stop, or pivot their projects at no commercial risk. Everything needed for designing specialized SoC solutions. Now that you've heard what we've been doing to enable our partners, let me share with you a few examples of how they're developing new specialized processors to accelerate ubiquitous computing. Our longtime partner MediaTek have been delivering specialized processing solutions for many years in the mobile space. And recently they partnered with NVIDIA to announce a specialized reference platform for an AI-enabled thin and light laptop. We have several other partners in Taiwan in early stage development of specialized processors for AI, including SunPlus and Himax. SunPlus is developing an SoC that combines an ARM Cortex-A CPU, Mali GPU, and our Ethos neural processors. This SoC has been designed specifically for autonomous robotic industrial applications. Himax is working on their next generation AI SoC uniquely designed for always-on smart cameras that's based on the Cortex-M55 and Ethos U55 solution I mentioned earlier. And very recently, we collaborated with our partner Arçelik, a major appliance manufacturer in Turkey, on a thought experiment to see if adding AI to existing refrigerators could help reduce energy consumption. Now, for context, refrigerators are typically the second biggest consumer of electricity in your home, gobbling up 13% of your total energy bill. I didn't realize that, actually. Arçelik developed a lightweight reinforcement learning engine, RL, to be run on Cortex-M-class processors. They analyzed in-home behavior, not big data sets, to see if they could minimize temperature fluctuations that occur when you open and close the door. The smaller the fluctuations, the less power consumed by the compressor. Now, it found that such a system could reduce power by an estimated 10% in existing refrigerators with no additional bill of material costs. If you use better compressors to get the same result, it could add more than 30% to the retail price. Now, Arçelik extrapolated on their data and found that this technology were flashed in the refrigerators across Europe, it could eliminate the need for 9 power plants. Just think of that. 9 fewer power plants by taking advantage of processing power that's already there with a fairly sim models and data sets. That's amazing. Looking ahead, we see an incredibly bright future for what's possible in the ARM ecosystem. Now, especially when you consider the future of ARM with NVIDIA. The combination of ARM's compute platform and ecosystem with NVIDIA's deep expertise in artificial intelligence will create the world's leading company for the edge of AI. A combination that will bolster our R&D capability, lead to new and exciting products that will further accelerate ubiquitous intelligence. Now, I am personally very excited about the opportunities we can provide to our partners as one company. There are so many ways that ARM is accelerating ubiquitous intelligence, and today I've just scratched the surface of what we're doing to enable it. But the one thing that is clear is that the type of intelligence does not happen without specialized processing, and ARM is the world's most popular specialized processing platform. And our new ARM v9 architecture will be the foundation for the next decade of compute as specialized processing becomes the new norm for computing. Thank you for your time today. I look forward to seeing you all in person next year at COMPUTEX. 谢谢。